Okay, good evening, everyone. This is day 2 of week 7. We are continuing on with learning about Terraform. Yesterday, you guys went over Terraform, an introduction of Terraform, how to install it, the components used within the files to create your infrastructure on AWS, and the commands to do it. Today, we will continue to learn more about it, but also get into introducing data blocks and import blocks. So let's go ahead and get started with the lesson. And before we do, can you guys see my screen? GitHub? Sounds good. All right, so real world infrastructure isn't built from scratch. You work with existing resources, shared infrastructure, and gradual migrations to infrastructure as code. Data sources let you reference existing infrastructure without taking ownership, while import brings existing resources under Terraform management. These capabilities enable you to adopt Terraform in any environment without disrupting existing systems. So think about when you go join a company and they've had infrastructure already set up or something like that, and maybe you have to or you're helping a company work on their infrastructure. Uh, this is Today's lessons can help you with that. What are we trying to accomplish? We'll learn to work with existing infrastructure using Terraform's data sources and import functionality. You'll import your day one EC2 instance, reference shared class infrastructure, and build automated deployment patterns that work with mixed infrastructure environments. Along the way, you'll understand when to use data sources versus import, implement launch templates with automated configuration. So a launch template is just what it sounds like. It's a template for EC2 instances so that you can configure everything with the same settings and configurations, and deploy containerized applications. So we have one lesson today that is on data sources and import. We have our lab and our assignment where you will be deploying an automated web server using Terraform. TLOs for today: master working with existing infrastructure using Terraform, understand the differences between data sources and import, implement automated deployment patterns with mixed infrastructure. And then our ELOs are use data sources to reference existing infrastructure without ownership, import existing AWS resources into Terraform management using Terraform import, understand when to use data sources versus import based on ownership requirements, create launch templates with user data for automated instance configuration, deploy containerized applications on imported infrastructure, and reference shared infrastructure while maintaining proper separation of concerns. Are there any questions before we continue with the lesson? Okay, let's go ahead and get started. So Terraform day 2, data sources and import. The problem: infrastructure you didn't create. Yesterday, you learned to build infrastructure from scratch using Terraform resources. But here's the reality: most of the time, you're not starting with a blank slate. Picture this scenario. You join a company that's been running AWS infrastructure for 3 years. They have hundreds of EC2 instances, dozens of VPCs, and complex security group configurations. All of it was created manually through the AWS console by previous engineers. Your manager says, we need to start managing this infrastructure with Terraform. Do you delete everything and rebuild it from scratch? Absolutely not. It's going to take a long time. That would be like demolishing a fully functional building just to get proper blueprints. This is where data sources and import come to the rescue. So data sources, reading existing infrastructure. So a quick summary of it is pretty much when you have something already set up in AWS, you can pretty much read all the data about that specific resource, and use it for your own configuration or whatever you need to do with it. So data sources are Terraform's way of saying, I didn't create this, but I need to know about it. Think of data sources like reconnaissance missions. You're gathering intelligence about existing terrain before planning your next move. You're not changing anything. You're just observing and collecting information you need for decision making. Data versus resource blocks, the fundamental difference. Resources are like construction orders. You're saying, build me a house with these specifications. Terraform creates, updates, or destroys that infrastructure. And Terraform manages the entire lifecycle. It also shows up in your state file as something Terraform owns. Now, data source blocks are like surveying existing buildings. So tell me about the house that already exists at this address. How many bedrooms it has, how many bathrooms. Terraform reads information, but doesn't change anything. Someone else owns and manages the infrastructure, and it's used to gather information for your own resources. So real world data source examples. So for scenario one, using existing networking, your company has a VPC that was created years ago. You need to launch new EC2 instances in that VPC, but you don't want Terraform to manage the VPC itself. So to read the existing VPC information, you would use the data block and then specify which resource, so AWS VPC. And this, again, is just for the name of this specific block so that you can reference it throughout your Terraform files. So this one is called existing company VPC. And then you have the filter, and it's just specifying the name and the value so that it can find the exact VPC that you're looking for. So for instance, this VPC on the console, you would see the name as company main VPC. And this is linked to this specific tag. And also, I don't know if you guys learned about this yesterday, but to name EC2 instances, the ones that you've created through Terraform, you would just put a tag argument within the block itself so that you can actually have a name once you create it. Because sometimes if you don't do that, or if you don't do that and you create the EC2 instance, you'll see it on the console without a name, and it'll be difficult to find which one you created. So we find the VPC information, and then the second block right here is actually creating a new EC2 instance within that VPC. So we specify it's a resource block. So we want to manage that. We're managing the EC2, so AWS instance. And then this is the name again for this specific block. And then we specify the AMI we want, instance type, and subnet ID. And of course, if you try to run this right now, it's not going to do anything. You would have to have another resource block to create that subnet. Any questions on that? So pretty much, again, to recap, you're just finding the VPC information with a data block, and then you're creating a EC2 instance within that VPC. Scenario two, finding the latest AMI instead of hard coding AMI IDs. You can dynamically find the most recent Ubuntu image. So this one is just finding the AMI. So again, we have a data block. We're specifying which resource. So it's AWS AMI, and then we're just naming this code block. We want the most recent true, and then we specify the owners. I guess it's the Ubuntu publisher. And we use the same filter from earlier to find which one which Ubuntu image we want to locate. And then once we find the AMI, we create a resource block with wanting to modify the EC2 instance, code block name, and then for our arguments, we just have AMI, and that is equal to the information that we got from the data code block. Any questions on that? Okay, so next up is Terraform import, bringing existing resources under management. Import is like adopting infrastructure. You take something that exists and tell Terraform, this is mine now. I want to manage this going forward. When would you use import? Import is perfect when you have critical infrastructure that was created manually. You want Terraform to manage existing resources going forward. You need to make changes to existing infrastructure using Terraform, or you're gradually migrating from manual to infrastructure as code. When not to use it, don't use import when the infrastructure is temporary or you don't need to change it. When someone else owns and manages the resource, when you just need to read information about the resource, you would use the data source block instead. Or when the resource is complex and would be easier to recreate. So the import process, import requires 2 steps. Step 1, write the Terraform configuration. You must write the resource block exactly as it would have been created. So here we specify the resource block, the type, the name, and then we have our AMI and instance type arguments along with the other settings. And it must match the resource that you're trying to adopt or take in exactly. So,
Eric,
yeah, yep.
I don't know. Did you see Kathleen's question about
Uh, I did
the
not.
import populate the state file?
Yeah, I mean, that was just my question. Then I'm curious, like when you run Terraform import, I guess as long as you have everything configured properly, it would I guess yeah, just populate the state file and then that has all the information.
Yeah, so it would update the state file once you adopt it. So uh, yeah, everything would be transferred over to your ownership, and it would be then located within the state file. Whereas beforehand, before you do the import block, it's not going to be on there. Does that answer your question, Kathleen?
Yes, thank you.
Yep. Okay, so to recap, whenever you're using the for step 1, you have to make sure that everything matches the resource that you're trying to import. A good way to do that would be to use the data block. Step 2, you would run the import command on your terminal. So Terraform import, and then you would specify what resource. So this going back to this legacy server block, and then you would specify the EC2 instance ID. So this tells Terraform that instance with ID I something is now managed by the AWS instance legacy server resource in my configuration. So import plus resource versus data sources, when to use each. Import plus resource, you're taking ownership. So use this approach when you want to manage and modify existing infrastructure with Terraform. Example scenario, your company has a production database that was created manually. You need to modify its backup schedule, adjust performance settings, and ensure it's properly tagged. So you would create a resource block, specify the type, which is a database instance for RDS, and then the name. And remember, everything must match exactly how it is on the console. and then you would actually import the the database instance to your I guess you would import it to your uh state file. That I guess that's one way you could look at it. Like your state file is kind of like the deed. Everything on there is the contract. Everything on there you own. And then this part right here at the end is probably just the name of the database. So after import, Terraform now manages this database. You can modify settings and Terraform will apply changes. If you run Terraform destroy, it will delete the database. So be careful. Data sources, reading without ownership. Uh, so I kind of think of it as just like read permissions, I guess. Use this approach when you need information about existing infrastructure but don't want to manage it. Example scenario, your company has a shared VPC managed by the networking team. You need to launch instances in that VPC, but the networking team retains ownership of the VPC itself. So just to read everything, you would create a data block, specify the type, the name, the filter again. You're looking for this specific VPC named shared networking VPC, which is specified by these filters right here. And then after that, you would create a resource block, which will create your own instance using the shared VPC. It's pretty much the same example as the one you saw from earlier. You would choose the type, AWS instance, the name, my server, and then specify your arguments. The key difference, the networking team still owns and manages the VPC. If they make changes, your data source will automatically read the updated information. If you run Terraform destroy, it only destroys your instance, but the VPC remains untouched. So a practical decision framework, in order to decide what you need, ask yourself these questions. Do I need to modify this infrastructure going forward? If the answer is yes, then you would import it and then create a resource block to take ownership of it. If the answer is no, you would just create that data block. Second question, do I own this infrastructure or does someone else? If you own it, use import plus resource. If someone else owns it, just use data source. So pretty much if someone owns it and you don't want to take if you don't want to take ownership of the resource, just always use data blocks. What happens if I run Terraform destroy? Should it destroy this resource? Or should I be able to destroy this resource? Use import plus resource. Should I not destroy this resource? Just use data source. Last question is this infrastructure stable or changing frequently? If it's stable and owned by others, use data source. If it is changing and under my control, use import plus resource. So common data source patterns, finding resources by tags. So over here, it's looking for an EC2 instance that has production as the value for the environment tag. A second common data source pattern is getting account information. So this is making a data block and it's just getting the AWS caller identity. So your profile, your account, and this is just the name of it. There's no arguments put in. And then you're using it in other resources. So for this code block, you specify the resource, specify the type for the S3 bucket because you're trying to modify it. You name this specific code block and then specify the bucket argument, and then you're just changing the name to my bucket and whatever the data was that is stored from this data block. It'll just add it to the end of that name. Another common source pattern is finding availability zones. So you're creating the data block, looking at availability zones, name, and then you're just looking for the available availability zones. So after that, you create a resource block. You're modifying the subnet, name, and then you specify an argument called availability zone, and you're just getting the names of uh, or you're choosing the availability zone that was specified in this data block. Why this matters: in the real world, you'll rarely build infrastructure from a completely clean slate. You'll be working with legacy systems that need gradual migration to infrastructure as code, shared infrastructure owned by other teams, third-party services and external dependencies, existing environments that need expansion or modification. Understanding data sources and import gives you the flexibility to work with any infrastructure situation. You can gradually adopt Terraform without disrupting existing systems, reference shared resources without taking ownership, and migrate legacy infrastructure at your own pace. Today's lab will demonstrate this in practice. You'll keep your day one infrastructure running and create a new Terraform project that references it using data sources. This shows you how to build upon existing infrastructure without disrupting what's already working. Is there any question for today's lesson before we get into the lab?
So are we supposed to rebuild what we destroyed yesterday then?
Yeah, to be honest, I recommend just watching me go through the lab, and then the challenge for today is pretty similar to the lab. So you can just reference everything we did over here just so you fully grasp it and understand it. But again, it is up to you guys and how you learn and your learning style. But I will be before we start the lab, I will be creating my infrastructure from day one. So to answer your question, yes, in short. Okay, so are there any other questions? Okay, let's get started with the lab. So Terraform Day 2 lab, data sources and import, prerequisites, rebuild your day one infrastructure. So let me just go ahead and do that. Wait for a second. I thought I deleted my my configuration from yesterday, but that's good. It's still there. Okay, just to go over what we have in the uh, main Terraform file, we have our provider, which is we're using AWS. We're specifying the region and the profile. So the region we are using is US East 1. The profile is just what profile you're pretty much using on your CLI. To check that, I think you do AWS configure list in the terminal. And this is the profile we are currently on. It says US East 2 for our region, but since we specified it here in US East 1 within the Terraform file, it's going to create everything within US East 1. And then we're specifying the Terraform configurations. So for our required providers, we're using AWS. Our source is HashiCorp/AWS. Our version is anything above 4.16, but less than 5. You guys know what this means? So this, I forgot what it's called. The squiggly line plus the forward arrow. It's pretty much specifying that I want to use versions that are any versions that you find that are higher than 4.16, I want you to use, but I do not want it to move on to the next version up, so like 5 or 6. So it stays within 4. And also later, I'll show you guys how to create some variable files so that you can not hard code your information within the files. So this is just our provider informations. And then we have our EC2 instance. We have our resource block, the type, and then the name. I just named it my EC2 test. We specified the AMI, this for Ubuntu. And then instance type, T2.micro, specified a security group. We have the key name, so the PEM file, the PEM key file. And then this is what I was talking about earlier. If you don't add this specific tag argument, when you create this EC2 resource, it's just gonna populate in your console without a name, so it'll be difficult to find it. So I just named the EC2 instance the same as what I named my code block, my EC2 test. Below that, we created our security groups. So resource, the type, name, and then we're naming the security group my AWS SG test. Just gives a quick description of it. And we have our ingress and egress. So ingress is inbound, egress is outbound. And then, so actually this, I believe this would be the tag itself. And then this is actually the name that you would see on the most left-hand side when you go visit the security groups page on AWS. It's kind of backwards, I know. And then we have our outputs. So we have the output block and then the type public IP, or this the output name public IP. So you can change it to whatever you want. And then the value, we specify that we want to collect it from the AWS instance block. Name of my EC2 test and just get the public IP from that. Any questions? We're gonna go ahead and just do a quick validate. It was a success. Now we can do a Terraform plan. So again, the 3 most important commands are pretty much I always just do validate, plan, and then apply. And of course, when you first set it up, you'll do Terraform init. So we do Terraform plan, and it's just planning everything out for us. A good indication of what will be created or destroyed will be on the most left-hand side. It'll either have a plus sign or a minus sign. So if we didn't have this, if we already had this resource created and we did if we already had this EC2 instance created and we did a Terraform plan, it'll probably have a minus on it saying that we can delete it. But since none of these are up yet, these are all going to be pluses. And the reason why I'm telling you this is because it's a good thing to look at this just to for like troubleshooting purposes or anything that you might run into. So since we did a Terraform plan, we can now do Terraform apply since everything looks good. We'll do a yes. There's also an argument that you can add to Terraform apply to skip this little pop-up. But I don't really like to do that. I like to actually go through the process just in case I miss something. I mean, it's probably not going to be anything I'll miss, but it's just be on the safe side. All right, so now it created two resources, which is going to be the EC2 instance and the security group. And since we specified that output block, it also gives us our public IP for our EC2 instance. Let's go ahead and log into AWS, sign into the console just to verify it. And we do have a my EC2 test instance that is initializing. Let's see if it already attached the security group. We do have the security group we just created for that is named my AWS SG underscore test. So we have rebuilt our day one infrastructure. We noticed that it gave us our public IP for the output after we hit Terraform apply, and we're going to keep this running. So for our project setup, I'm going to actually move this to a new window and move it to my other screen. So if you don't have a directory already for day two, just go ahead and create one if you're following along. I already have one created, so I'm going to CD into it. CD week 7, day 2. Just hit tab, do an ls, see if anything's in there. Nothing's in there. Then I'll create a new, we're going to open a new VS Code window. Okay. So we have created our directory for our week 7, day 2 lab. And now we will be creating a few files. So we'll just do a code main.tf, and then we're also going to create user data.sh, which is going to be our bash script. This is going to be used to update everything within the server that we will create in this lab. I'm gonna go ahead and press Command S, just so I can see it over here. And that is populated. Next thing we're gonna want to do is initialize Terraform. So Terraform init. So it has been successfully initialized. One thing I want to say too is when you're going through and learning Terraform, it's good to have like a little note page or something on the side so that you can write down every command that you run so that you can, because Terraform is kind of has a similar process for everything, so it'll help you with future projects as well. You just keep a log of everything that you've done for a project. So we ran the command Terraform init to initialize Terraform. It's successful. It says we can now begin. So for our first file main.tf, we're going to specify the providers. One way I like to keep everything clean is kind of just do a / and then specify the section, what the section below is going to be about. So this one is going to be providers. So I'll just copy and paste that code block to the file, and we'll just quickly go through it. So this is specifying the Terraform configuration. So we want required version of at least 1.0. We want to use AWS with the source HashiCorp / AWS and then version. Over here it says 5.0, but so for some systems, depending, the latest versions give you an error with timeouts and all that because it is not configured to work, for example, on like Apple Silicon chips, and it's built to work on Intel. So I know 4.16 works on my machine. That's why I'm using it, and I will change it to that. I think the latest version is like 6.0 or something, and that I was having problems with getting that to work on my machine. So I just changed the version. Don't forget to hit save. And then we will specify our provider, which is AWS, and then the region we will be using and our profile. So it's AICO-Delta Eric. In my case, it will be different for yours. And then just to quickly go over it. So I can show you guys how to use variable files so that you don't have to hard code all these in, and you can reuse them for different resources. Just give me 1 second. So first thing you want to do to utilize variables is to create a file called variables.tf. So variables.tf. We're going to go into the variables.tf and just specify the code block. So pretty much for all of these, each code block that you put is going to have the code block type of variable. So just type in variable, and then in double quotes right after that, you're specifying the name of the variable that you want to use. So we'll do a app region for this one. And then put a space in between, create some squiggly brackets, press enter. And we have to add a description. And we'll just put specifies which region in AWS to deploy infrastructure. Again, you can put anything within the description argument. It's just to help you remember what that specific variable is doing or what it's used for. And then the default for this variable, we will specify as US East 1. So now we have our variable for our app region that we can utilize in the main.tf, but we still have to create our profile variable. So we'll just pretty much do the same thing, variable, in double quotes, specify the name that you want to use. So I'll do AWS profile, do a squiggly bracket, and then again, type in the description. And for this one, we'll do specifies which AWS account to deploy infrastructure on. After we create our description, we will do a default of what we want the value to be. And then I'll just put my AICO-Delta Eric profile. Let's go ahead and save that. And then now we can go back to the main Terraform file.
For that one, is that so is that your username?
Yeah, so this is one of the profiles that I have within my AWS CLI. So over here, I think I forgot what the command was. I think it's AWS list profiles or AWS configure list profiles. So this is all the different accounts that is set up within my AWS CLI on my system. So I have these three, and I'm specifically wanting to use this one because these all point to different accounts. Does that make sense?
Yes. I'm just looking at the ones that I have and realizing I need to figure out what those are.
And then you can actually check which one you are currently using by typing in AWS configure list. And then this is what is currently configured on your system. So it'll show you the profile, region, and all that.
And if it says not set,
If it's not set, you can do export, and then depending if you want to change your profile or region, you would do AWS underscore personal. Let's do a region. If you want to change your profile, you'll put profile instead. I think I might be missing a dollar sign, but let's do US East 1. Might be lowercase.
I mean, if nobody else has this question, like I can just look it up. Thank you very much, so.
Yep. Yeah, so it's pretty much this format right here. I don't remember if I have it in like correctly the right format, but follows this in that sense. Okay, so going back to the variables.tf has we have created variables for our region and our profile. We can go back to the main.tf and specify those. So for region, we can just do we can delete everything right here, and we're gonna reference the variable that TF file. We'll just do app region, and then same thing for here, var dot AWS profile, and that's how you would make sure that nothing is hard coded. So we have put in our providers. Now we are going to add a data block to read from one of the security groups that is already existing within AWS called class shared SG. On GitHub, it says for the value of the name for the filter web security group, we're going to change that. Or what do we have on our? Actually, we can leave it because it's going to reference this specific security group right here from our day one. So we'll just go ahead and copy and paste that block. So we specify uh the that it's a data block, the type of resource we want. So security group, and then the name for this block. We're gonna filter it for the name and looking for the value web security group, which will again reference the security group from day one. And for here, I'm just gonna put a security group. So to go over it again, data is for the block type for reading existing infrastructure. AWS security group is the type of AWS resource to read. Class shared SG is your custom name for referencing this data. The filter is how to find that specific security group. And then this argument right here is specifying search by the name tag, and then values, the exact tag value to match to.
Hey, Eric.
Yep, go ahead, Cam.
Um, I understand the logic of that. The thing that like so if there's more than one web security group,
Hmm.
I think it's gonna throw error then, right?
Yep,
And so if
yep.
we're creating this, we're essentially creating two if we already created one, right?
Uh,
Like we just did day ones, we just spun it back up,
mhm.
which then created a web security group. And if
Yep.
we're gonna do this again, it's gonna create a second one.
So for this one, since it's a data block, we're not going to be creating it. So we're just going to be reading
Oh, gotcha.
all the specifications and configurations from the
Hmm.
security group from day one. Does that make
Okay.
sense? It's because
Yes.
yeah, it's because so whenever you see a data block, you're just pretty much reading, and then if it says resource, then you can you have those right permissions. Does that make sense, Cam?
Yeah.
All right. Any other questions? But you are correct in the fact that if you try to create it and there's already multiple or even one web security group, then it's gonna throw an error.
Hmm.
Okay, so step 3, we're going to add the resource configuration to main.tf. So again, let me go back to oh, well we're just yeah, so we're just reading using the data source, and then we're creating I think an EC2 instance. Yeah, we're reading from the data from the security groups, all the information about it, and then we are going to add a resource block for our EC2 instance so that we can create it, or actually uh import from our existing EC2 instance from day one. So we'll just go ahead and copy and paste this block. So we'll just quickly go over it. So resource we're specifying is for the EC2. We're naming this block as imported server, specifying the AMI, instance type, key name, and the security group. For this key name, I am going to change it to the one that I have on my local system because later on we will be SSHing into the server. So I am going to use my PEM key. Let me look up what that was. Because otherwise you would have to download that lab key that was previously on here, which I don't even think you can do on AWS. I think you can only download your PEM key after you created it. So for this key name, this is specifying what PEM key file it will be using. So just put yours on it. Security group, we are referencing this specific security group or the specific data information from this data block. That's why it says data. So it's using data block and then specifying the type, the name of that data block, and then the ID. So that we can link it to our EC2 instance. For our tags, we have Terraform lab server. That's what we will be referencing it as. But I am going to go ahead and change it to match my EC2, my EC2 test. Kind of same thing as this one. And then after you create that, you kind of just want to, one way is you can just reference the EC2 that you created from day one and go back and just check your AMIs, instance types, and everything is the same, which it is. So we're good on that. Good. We do a Terraform init already. We'll just go ahead and run a Terraform init again. It's not going to hurt anything. Actually, we did not run a Terraform init because the state files and log files didn't populate until we have ran the command. So after doing these steps with making the data block and the resource block, we want to go back to our day one directory and just get the instance ID from the EC2 instance that we created then. So for that command, we will be running this Terraform show. We'll pipe it into grep and then find the ID. And it returns us the instance ID right here. So now we will copy that instance ID and we will go back to our day two and we will run this within the terminal. So we will do Terraform import, which is how we will import that EC2 instance to our state file. And then we'll specify AWS instance dot, and then specify the name right here, and hit the space bar and paste in your instance ID. So we're importing this EC2 instance. Press enter. Multiple EC2 security groups matched. Use additional constraints. So what Cam was saying, there's a lot of the same EC security groups. So we'll need to modify the value. What does it say? Line 21.
Yeah, I think because in if you look at the AWS console in the security groups, there's
Mhm.
two web security groups. And so I think it's just it doesn't know which one.
Mm-hmm. So there's two web security groups. I'm just going to highlight those by clicking on the left checkbox. Look, they're both now highlighted. One way to look at it is under the security group name. So this one's my AWS SG test. This one is just my AWS SG. So I'm guessing this is the one that I created. We continue on further. I thought it was going to give us the timestamp, but yeah, that's one way you can look at it too. It's just for the security group name. I'm gonna go ahead and modify this to just web security group 1, and then go back to my day 2 configuration file for the values under the data block. Specify that security group that I just modified. Any questions on that part? Okay, we'll try again with importing it, see if it works. And it is successful. So the resources that were imported are shown above. These resources are now in your Terraform state and will henceforth be managed by Terraform. One thing I like about Terraform is it really gives you good messages with helping with troubleshooting, or if something's wrong, it'll really specify what went wrong, and it's not just like a block of text that you have to parse through and dig through. So that's one thing I like about it. So we imported our EC2 instance. What it did was it tells Terraform this existing instance is now managed by our configuration. Terraform takes ownership and can make changes now going forward, and the instance becomes part of Terraform's state file. We're gonna verify that the import worked by doing Terraform plan. Let's see what we get. So no changes, your infrastructure matches the configuration. I see green, so everything is all good. Terraform has compared your real infrastructure against your configuration and found no difference. No changes are needed. So it says you should see a plan to update the security group assignment. Why did anybody else get something different? If you're following along. All right. I don't see any any errors or anything wrong with it. So let's just keep going forward until we do run into one. So if it said something about specifying that you need to update the security group assignment, then you would do Terraform apply shortly after to make those changes. But since everything is good on my end, I'm not going to run that command. So now we're going to go into our bash script, and we're going to go ahead and copy and paste this block. So this script pretty much prepares a brand new EC2 instance with Docker, Git, GitHub CLI, Node.js, a directory for our application that we will be deploying, and a log confirming that the setup ran. It's perfect for spinning up a dev environment. So we have our I forgot what this is called, but you need this in all your bash scripts all the way at the first line. And then the next part just updates our system packages. We install Docker shortly afterwards. We install Git and the GitHub CLI. We install Node.js. We create a directory called app within this path. And then we do log completion, just saying launch template, user data completed. It just gives us some text. So this is pretty much setting up the EC2 server that we're about to be deploying. This is what this is doing. So I guess so Terraform is creating the infrastructure, so the buildings and everything. And then I mentioned Ansible before. This is kind of like what it would be doing. Ansible creates or sets up everything inside those buildings. So like the furniture and everything, TV, all your utilities. So this the same thing what this bash script is doing. After we create our bash script, we're going to add a launch template to our main Terraform file. I'm just gonna leave it under the EC2 section because it is a template for EC2s. And we're gonna copy and paste this code block within it. So let's quickly go through it. It's creating a resource. We're specifying that we want to modify or create launch template. We're specifying the name of this block. And then for our arguments, we have the name prefix. So Terraform app, and then it'll just add on random number. Afterwards, I'll show you guys after in the console once we build it. The image ID should match your day one AMI, your instance type t2.micro, and then the PEM key that you want to utilize, which I will be changing to mine. And I'll go ahead and save that. It's saying to use the shared security group, which is another security group, which is different from the web security group. So I created another security group called class shared security group that we can use for today's class. So it's referencing that. And then this user data argument is just pretty much saying, grab this bash script that we just made and run it after we create our instance. So it sets everything up within the EC2. We have our tag specifications. So resource type instance, and then name and created by. Gonna go ahead and change this to my EC2 test. And we have created our launch template. Any questions? Okay. So key points, launch template references the shared security group using data source, user data. The user data argument is the automated configuration script that runs on boot. And then Terraform reads and encodes the user data script from this part right here. And future instances launched from this template will auto-configure themselves, saving you from running all those commands manually and using up a lot of your time. So step 7, we're going to add our outputs section. And we're just going to go ahead and copy and paste this block within the file. So for outputs, we have 3 of them. We have we want to get the imported instance IP. So the IP from the EC2 instance from day 1. We want to get the class shared security group ID. And then we want the launch template ID. And quickly, can someone just remind me what outputs are?
It's going to print it to your screen after you run it.
Yep, exactly. So after we have built our files, we can go ahead and do a Terraform validate. Just check for syntax errors. Everything is good. We'll do a Terraform plan. Just quickly go through it. Everything looks good. So the plan is to add 1 resource, change 0, and destroy 0. And then here's what our outputs are going to be. So we'll do Terraform apply. To secure those changes. So apply was complete. It added 1 resource. And then we have our outputs right here. Let's just go check and see if we have a launch template that got added. So on the left-hand side in the console, under launch templates, you can go over there. And then we do see that we have that Terraform app beginning. And then I think it's just specifying the date it got created in the time. So this Terraform app comes from right here. So we know that's the correct one and it got made. Let's go ahead and test launch. Let's test the launch template automation. See if the bash script creates everything. So within your terminal, go ahead and paste this command. So EC2 run instance is gonna pretty much launch an EC2 from this template. We're specifying the template ID, specifying the tags and the region. Press enter. We got a JSON, so seems like everything got created and is good. With 3 to 4 minutes for users. Go back to the instances, just double check to see if anything's initializing. I think this is the one that has the time. Yep, so it is creating an EC2 instance from the template. And we can verify that because it's initializing as well as the name and the time it was created. And I could also see my key name on there. Just for a sanity check, go ahead and copy this. Do Command F. Trying to figure out how we got that name test launch template. Any clues on how we got this name?
Would you go back to the
From the
Terraform
launch.
files?
What was that?
The tag?
Yeah, I was thinking that too. Maybe it adds a test in front, and then specifies launch template.
Check your instruction in your terminal. See the tag specifics?
Yep. Oh, okay, yep, it's right here. So for our when we ran that command, we wanted a tag for we wanted the name to be a test launch template, so that's where this comes from. Does that make sense? Good catch, Troy. Okay, and then so we see that the EC2 instance has been made. Let's go ahead and I think this command is just going to return us the public IP of that instance, which we can use to SSH. So I'll go ahead and copy that. And then we can do, honestly, I like just going to the console, clicking the EC2 instance that we want to connect to, press connect, and then I just copy this. And then since I have my PEM key stored in my downloads directory, I'm going to go ahead and go over there. You guys, I think you guys have it in actual SSH directory. So we have successfully SSH into our directory, or into our server. So now let's go ahead and just verify that everything within the bash script got ran and installed. So first let's check if Docker did. So yep, Docker got installed. Let's check Node.js. Yep, got installed. Let's do git. Yep. And then GitHub. Yep, so everything is good there. Our bash script ran everything like we wanted. So now we can go ahead and exit out of this. And then we'll continue on to deploying a simple web application onto our EC2 instance from day one. So that was just what we just did was kind of optional. It's just showing you how the bash script worked and that user data argument. So let's go ahead. And get the instance IP of the EC2 from the imported EC2 IP. So for that, within our terminal, we will go ahead and run this file. Make sure you're in the directory for day 2 so that you can reference this specific output. Press enter, and that's just IP. And again, that was used so that you can SSH into your console or your server. Just gonna go ahead and copy this and go into it through the terminal. So we have successfully SSH into the server. Now let's do an LS. There's no, actually, let's go back to the other server we created. One thing we also included in the bash script was to create that directory. So it did get created. So click on the zoom button. But yeah, there's a app directory here. So everything in the bash script worked correctly. Let's go back to our import EC2. Let's do an LS. Since we didn't utilize a bash script for this, it is plain and it is empty. So one thing we can do is just do a vim and then just name this bash sh, create a bash file, and then utilize that same bash script that we utilized earlier. So press I to insert, and then Command V to paste. Press escape, WQ to write and quit. Let's just double check it's there. Yep. Let's go ahead and add permissions to it. So let's do chmod plus X so that we can execute it. It has to be one word, I think. Actually, might have worked. We'll check. We'll see in a second. After you do that, go ahead and create actually it will run everything for us or create that app directory. So let's go ahead and try executing it. I don't think it's gonna work if we don't put in sudo, but let's try anyways. Yep. So it's asking us for a password. I don't want to put in a password. Do sudo. And now everything from the script is running. Any questions so far? There's the power of automation, does everything for you while you just kick back rather than spending like 10 minutes trying to do all this. And that way, when you're creating other EC2 instances, the chance for error is a lot smaller since everything is being ran the same. Whereas if you're doing it manually, you might get a typo or install the wrong thing. This really increases your workflow output. Let's go ahead and do an ls real quick. See if our app directory got created. It did. So now we're gonna go ahead and cd into that app directory. Do an ls, see if anything's in there. Should be nothing. And then we're gonna create a simple Express app. So Express is to Node.js as Flask is to Python. It's just a popular framework that makes it easier to build web servers. So let's go ahead and run this. We're just creating an app.js file with this information being loaded into it. Remember we mentioned I mentioned the EOF and the file. Everything between then is gonna get put into this file. We'll go ahead and press enter. Do an ls. Our app.js got created. So now we can initialize npm and install Express using these commands. We'll initialize npm by running this command and then install Express by running this command. I thought it was kind of cool how there was that little spinning thing. You can barely see that. So it added 65 packages and audited 66 packages. So everything is good, found zero vulnerabilities. Now we can go ahead and run the application by using this command. This is not going to work. Show you guys that right now. And I want to see if you guys can figure out why.
Why the app isn't gonna work, or why you won't be able to go to it?
Yeah. Why we won't be able to access the app. Let me go
What's
back.
the security group reference like settings?
Nope. Hold on 1 second. Let me just show you guys real quick. Yeah, so it's not working. You said security group. What do you think is wrong with the security group?
The HTTP settings would be if you can't reach it that way. Like the inbound rules would be off.
So we're currently on from what we put into the app or the Express application, we're using port 80. And then for inbound, we have port 80 specified, and outbound, we have all. So that's not gonna be a problem. Any other guesses?
Do we have anything serving the front end? Like Nginx or something like that? Or is that not necessary with Express?
Yeah, it's not necessary. One more guess, and I'll show you guys the answer. No other guesses? All right. So when you're in a specific port range, 80 being one of them, you have to run this command right here, using a sudo up in the beginning so that you have escalated privileges because this port is privileged and you need root privileges pretty much. So on Linux and Ubuntu, ports 0 to 1023, you're gonna need those root privileges to run. So if we cancel this operation and then do a sudo node app.js and then the &. Anybody remember what the & was? So the & is pretty much saying to run this command in the background so that you can continue to put in commands. So it's not like how when we were installing the packages, how everything's just going through and you're just sitting there. This allows you to just keep on working. But going back to our problem earlier, everything from ports 0 to 1023, you may need to use a sudo beforehand so that you're able to access it because it requires root privileges. Why? I cannot give you the answer, but you just need it. So app is now running on port 80. Shoot, I forgot to even change this to HTTP earlier. That's also another thing to look at if your application is not working, ensuring that you're either on HTTP or HTTPS. So that's usually one of the first things I look at. So let's go ahead and let's do HTTPS first. See if that works. Okay, now let's go do HTTP, and now it's working. So we have successfully deployed that application. Are there any questions so far too?
Hey Eric, this is Cam. If is it bad practice to change the port then where you're not using one of those special ports for Ubuntu? Or should you just do the sudo thing?
Yeah, just use the sudo because I mean it really depends. But for if you're using your own machine, just go ahead and use sudo. But like if you're at work or something, be mindful. For security reasons, you might just want to change the port. But
Okay.
yeah. Does that answer your question, Cam?
Yeah, I'm like from a what is the most secure way of doing things? Is it to do the sudo route or to change the port number?
I would say changing the port number because
Okay.
you'll know what it is, but sudo, you're just escalating your privileges and you might run a command on accident that you did not intend to run. So that's why that's my reason for saying that changing the port would be better for security purposes.
Okay. And then changing the port, could that cause some like stream issues as well? Like maybe like people use that same port number that we use or something?
Well, you also gotta take into account if you're using like load balancers or any proxies or anything like that.
Hmm.
Because with that, like I think Nginx, I forgot what exactly the port it uses, but it's in the higher numbers. And then you
Mm.
could still have your application be on port 80, so you're not modifying the port for
Mm.
that. But for Nginx, you can just go ahead and change it. Who really cares? But but
Okay, thank you.
yep. But yeah, you just gotta have most of everything. You just have to use your best judgment and take into account everything. Uh, okay, we tested our application. Let's run some Terraform state commands within our day 2 directory. So let's go ahead and run Terraform state list. I keep on doing that. I keep on doing Terraform instead of Terraform. So everything within the output that it just returned us is what's listed within our state file. So we have our data block. We're just reading the information from this security group. We have our AWS instance, the imported server. And then we have our AWS launch template, the app template. Let's do a second command. Which is Terraform state. So this is Terraform state list, this is Terraform state show. And we're just looking at that security group from that data block. And let's see what we get returned back. So when we do a Terraform state show, it just gives us all the information about that security group. The ARN, description, ID, name, VPC ID even, and our the name that we changed earlier. Now let's take a look at the imported server. So we'll do Terraform state show AWS instance dot imported server. See what we get back from there. And it gives us the same thing, AMI, ARN, availability zone it's in, and a bunch of other information, ID, instance type, state. It just gives you very detailed information. So again, the AWS instance dot imported server is right here. It's a managed resource. So you imported this and now you can modify it. That's why it's in our state file. The AWS launch template .app template is a managed resource as well. You created this new infrastructure. And then this security group is a data source. That's why it has the data in the beginning. And it references existing infrastructure. So it reads it only. Key difference, manage resources. Terraform can create, update, and destroy them. Data sources, Terraform can only read information about them. Key insight, you can modify your imported instance, but cannot modify the shared security group through Terraform that's managed by someone else. And let me switch this back over to the screen. Step 13, understanding import versus data trade-offs. What you accomplished today, imported EC2 instance. You now manage an existing instance with Terraform. You can modify the instance settings. You can add tags, change instance type, etc. And you can also destroy if you run Terraform destroy. We used data source for security group. You reference shared infrastructure. You can read security group settings for your own resources. You cannot modify the security group itself, but you also cannot destroy the resource by using Terraform destroy. We also created a launch template, which is a new infrastructure that builds upon both. It uses a shared security group via the data source. It can launch instances identical to your imported one. And it demonstrates mixing data sources with new resources. So for cleanup, before we, I can do this later, but are there any questions? Okay. So tomorrow you guys aren't gonna have class on Thursday since it's Thanksgiving. So class got moved to tomorrow. It's going to be a fresh start. The labs don't build upon each other, so it'll be easier to follow along with and go through. You'll be creating an entirely new infrastructure for the transcribe labs. What you've accomplished today, you've successfully rebuilt day one infrastructure from your existing configuration very quickly. Instead of manually going through the AWS console, you imported existing infrastructure into Terraform management, used data sources to reference shared infrastructure you don't own, combined imported resources, data sources, and new resources in one project, created automated launch templates that reference shared infrastructure, and deployed a simple web application using infrastructure as code. This demonstrates real-world Terraform usage when you work with a mix of existing infrastructure, shared resources, and new deployments. These skills are essential for any organization adopting infrastructure as code practices. So a quick reference, day one versus day two workflow. Day one was a manual setup, and then day two was automated and used importing. This progression shows how infrastructure as code evolves from manual configuration to fully automated deployments. Any questions on our lesson today? Okay, if there's no questions, let me just go ahead and go through the challenge real quick. So you're pretty much going to be doing the same thing we just did. I'll go ahead and work on uploading the recording right after this. So you're going to be creating a fully automated web server that displays content using Terraform. Your goal is to open a web page in your browser, see information displayed on the page, and know that everything was set up automatically by Terraform. You can access your web server on port 80, set up your project, build a web server, create a launch template, and test everything. 3 files you'll be using that you need are the main Terraform files and user data bash script. And instead of putting the outputs in the main.terraform file, you can put it in a Terraform file called outputs. And that's another thing about Terraform. You don't have to put everything in the main file. So you can pretty much split them up and chunk them up, decouple them, so that everything is easier to find instead of having to parse and read through a long main.tf file trying to find that specific resource that you want to update. What goes on each file is listed right here, and then just give you some instructions to follow. Are there any questions? If there's no questions, go ahead and take your 15-minute break and then just be back and get working on this. If you guys need anything, I'll be over here. Just ping me, ping one of the TAs, and yeah, go take your guys' 15-minute break.